Okay, welcome along to this video, and the way this is going to work is this is for paper 2 and it's for foundation, paper 2 being foundation. It's going to be like a two-part video. This one is going to be looking at the sort of the basic and the fundamental number skills, so things like timesing decimals, fraction work, indices stuff, okay, stuff kind of at the start of the papers that is important that we get it correct, but also things like timesing and dividing fractions, things that will be very important skills to have later on for the latter questions in the paper. Okay, so this video will be on that kind of stuff, so looking at kind of important number skills. I will do a second video which is going to be on these type of questions where myself and Mr. Gibson have really looked at what could come up on paper 2. And look, there could be other topics that come up, of course, but I've just picked out a few. So things like trigonometry with exact values, factorizing, a bit of a classic one. You've got angle stuff, okay, so there's quite a few different variations there. Polygon stuff, more factorizing. Loci is a classic non-calculator one. Plotting graphs, non-linear, again more sort of forming and solving equations and angles. So yeah, but this video is going to be on important number skills. Okay, so this video, just a bit of a brief outline, is going to be timesing, dividing decimals, timesing and dividing fractions, where you can sort of see you've got this kind of scenario as well. Simplifying fractions. You've got indices with negative powers. You've got roots in there, okay, including cube roots. And you've got squares of negatives, so quite awkward questions. A bit of BIDMAS and a bit of kind of, we call this director number, but it's just like negative number stuff that can often cause a bit of mayhem. And then a bit of estimation, a bit of rounding to significant figures and to decimal places, and then a bit of indice work. Okay, so this is like what we'll go through in this video. It'll probably be about half an hour long. Actually, what time is it? It is, okay, I was trying to do this in about 30 minutes. Okay, so let's go through these. So what you can do is you can try them as I go through, and I'll go through each of the questions. Now, question 1 is looking at multiplying decimals. Now, when you get questions on timesing decimals, I always think, well, roughly, what would the answer to this question be? 4.7 is roughly the same thing as 5, and 2.8 is roughly close to 3. So 5 times 3 is 15. So you sort of know that this answer should be close to 15. So when you kind of get your answer at the end, it should be roughly around about 15. Okay. Now, when you times decimals, you want to times them as if there was no decimal. So we're going to write this as 47, and we're timesing it by 28. Okay, and we can deal with the decimal at the end, but we know it's roughly going to be equal to 15, and we're timesing. So we'll just go and work it through. So we do 8 times 7, which is 56, and it's quite important that we're just laying things out nice and neatly. Then we can go and do 8 times 4, which is 32, and we add the 5, which is 37. So we go and put the 3 and the 7 in there. Your second row, you add a 0 because you've got two numbers that you got down here, and you're going to do 2 times 7, which is 14, and we carry that 1. And then we've got 2 times 4, which is 8, add the 1, which gives you 9. And then we just got to be a little bit careful as we add these together. Okay, so we go and do, and I've written these numbers, the 5 and the 1 numbers that we carried over, really small, because you do not include these when you add your numbers together. So we go and do 6 at 0, which gives you 6, 7 at 4, which gives you 11, carry that 1, 3 at 9 gives you 12, add the 1, gives you 13. Okay, now we said that this is going to be roughly equal to 15, so 13.16 is the reasonable answer here. Okay, if you put 131.6, well, clearly that's way too big. If you put 1.316, clearly that's way too small. So 13.16 is going to be your answer for the first one. Okay, so that is the first answer. Good. Okay, there we go. Let's give that a highlight. There we go. Question 2, the one below it down here. Now this can cause a little bit of confusion. Now this one, right, you've got 0.2 times by 0.8. It's similar sort of thing to one above, but you've got zeros at the start. Actually here, I would just go and do, first of all, well, what is 2 times 8? Okay, and 2 times 8, of course, gives you 16, but of course that is not your answer. Now, because you've got 2 numbers that go after your decimal points. Okay, so the points being here, you've got one number after it and a second number after the points. That means you go back in by 2 spaces from your number. So the point goes in here. So you get 0.16, which is the same thing as 0.16. It's the same thing as the previous question, right? With this answer, because you had the 7 and the 8, which is 2 numbers after the point, you go back in by 2 places to put your point where it goes here. Same thing here. Okay, you go back in by 2. You've got 2 numbers after the point, so this is your answer. Okay, there we go. Now, just be a little bit careful here. If you were given something like this, let's go and do it in green. Sorry, this is a bit of an additional question. If you were given 0.2 times 0.3, right, often students would write here 0.6. That is not correct. Okay, well, 2 times 3 gives you 6. And again, because you've got 2 numbers after your point, you've got to go back in by 1 and 2 spaces over here. Okay, so we've got 1, 2, so you get 0.06, and 0.06 is 0.06. So just be a little bit careful with that variation as well. Okay, so that's that. That's looking at times in decimals. Hopefully that was clear. Now on to dividing with decimals. Now, if you are dividing by a whole number or an integer, you are good to go. That's really, really useful. So this one, you just go and do a bit of bus stop. Okay, you just go and say, well, how many 5s go into 3.8? Because this number, the thing you are dividing by, is a whole number. Straightforward. 5 into 3 doesn't go. It is too big, so you can go and put a 0 up here, and you bring up the point, and you carry the 3. Now, 5 into 38. Now, if you're kind of struggling with your division here, write out your times table of the number that you divide by. So write out the 5 times table. So 5, 10. And just go up to 10 times that number, and you're going to be absolutely safe with these questions. There we go. So you're saying how many 5s go into 38? How many can you fit in fully before it goes too big? Well, you can get 1, 2, 3, 4, 5, 6, 7. Gets you to 35. You want 38, so 7 is good. 7 gets you to 35, and you've got 3 left over from 35 to 38. So you've got to go and carry a 3 over. When you carry the 3 over, you add a 0 in the bus. And then, well, 5 into 30 goes 1, 2, 3, 4, 5, exactly 6 times. So this is going to be your answer. Okay, so 0.76. That is the answer. Now, this question below, right, because you're now dividing by a decimal, you've got to change that. And the way that you change that is by upscaling by powers of 10. Now, I know that if I go and do 0.2 and I times it through by 10, or 0.2 times 10 will give me 2. Because I times this number by 10, I must do the same thing over here. Okay, so well, 0.2 times by 10 gives me 2. So that's good. And then if I times this number, by 10, it will go to 3.8. So I've got 3.8 divided by 2. This calculation and this calculation will give me the same answer. Okay? It's a bit like, just to show you why, it's a bit like if you had something like, I don't know, 20 divided by 2, that of course would give you 10. If I times those numbers up by 10, so 20 times 10 would give me 200, and 2 times 10 would give me 20, well, 200 divided by 20 also gives you an answer of 10. Okay, so they give you the same answer. Okay, so now this is the same thing as before. We can go and set up our bus stop and say 2, give myself a bit more room, so 2 into 3.8. And you could write up the 2 times table, I'm not going to on this one, but 2's into 3, you can get 2 in one time before it goes too big, and you can bring up the point, and because you got to 2, you've got 1 left over, and then you've got 2 into 18 goes exactly 9 times. So 1.9 is your answer. There we go. Good. Again, the one below, question 5. The issue here is you are dividing by a decimal, which you want to change. You want to make this a whole number. Now this time, I wouldn't times it through by 10 because that would get me to 0.2. I'm going to times it through by 100, which means I must do the same thing also over here. Because now if I times this number by 100, it will get me to 2, because the point will move up by 2 spaces. So I will go to 2, and I'm dividing 0.21 times 100 will give me 21. So I've now got 21 divided by 2, which you might know is 10.5, but always a good thing to work through in the exam. Your bit of bus stop, 21. Now 2 into 2 goes exactly 1 time. 2 into 1 is too big, so 0. And now we've got to go and put in a point here, another 0. And because 2 couldn't go into 1, it was too big, you carry this 1 up here. And you say, well, 2 into 10 goes exactly 5 times, and you bring up the point. Okay, you put this point up. So 10.5 is your answer. Okay, question 6. Now on to sort of timesing and dividing with fractions. Now, this is just knowing, right, if you're timesing fractions together and one of your numbers is a whole number, write this number as a fraction. And 4 is the same thing as 4 over 1. Because this really means, this means here 4 divided by 1, which gives you 4. These mean the same thing. Okay, 4 is the same thing as 4 over 1. So if ever you get given a whole number in a fraction, I would write it as a fraction. Okay, so we're doing this, and we're timesing it by 2 over 7. Now, timesing fractions is really straightforward. You just times your numerators. So you're going to do 4 times 2, which gives you 8 over 1 times 7, which gives you 7. And this is your answer. Now, the question in the exam might go and say, leave your answer as a mixed number. If that was the case, where you're sort of saying, because this is a top-heavy fraction, the numerator is greater than the denominator, you can say, well, 7 goes into 8 exactly 1 time. And then from 7 to 8, you've got 1 left over. So 1 left over, and you always put it over the bottom number of your fraction, which is 7. So these two things here, they mean the same thing. They might just ask for it in a specific form. Okay, so that's your top-heavy fraction, and that is your mixed number. Okay. This one here, dividing fractions, is knowing that you need to keep the first one the same. You take the reciprocal, so you flip the second one, and you change your sign to multiplication. So we keep the first one the same. We flip the second fraction, which really means taking the reciprocal, but that's fine. We change your sign to multiplication. And then we can just go and do 4 times 3, which gives you 12, over 5 times 1, which gives you 5. And this is your answer. But again, because you've got a top-heavy fraction, you could write it as a mixed number also if you wanted to. So you could go and say, well, how many 5s go into 12? Exactly 5, 10. 15 is too big, so 5, 10. So it goes twice, gets you to 10. And you've got 2 left over to 12, so 2 over that 5. So both of these things, they mean the same thing. Again, they might ask for a specific format. Now, question 8 says simplify this fraction. Simplify means you want to write the fraction so you can't divide through by any other number. Now, if you try to work this out, that would be very, very difficult because you've got 12,000 divided by 500. But it's just recognizing here that because you've got zeros on the ends of both numbers, well, if I cancel out these zeros, you are effectively dividing the top and bottom by 10. If I cancel out these zeros, you are dividing through effectively by 100. So you can just knock off as many zeros on the top and the bottom as you need. So what I've done here is effectively divided through by 100. So I'm left over with 120 over 5. Now, because actually 5 is prime, I can't simplify this any further. This would actually be my answer. Now, that is your answer. You might actually have a scenario where you want to get this into a decimal, but now this becomes quite easy. Okay. Well, this isn't our final answer because we can now go and say, well, what is 120 divided by 5? This means a fraction is division. 120 divided by 5. You are saying how many 5s go into 120. Now, you might know that's going to be equal to 24. If you didn't, bus stop again. Okay, so 5 into 1 goes 0, carry the 1. 5 into 12 goes twice, remainder 2. And 5 into 20 goes exactly 4 times. So to simplify this, actually, you do get down to this fraction. but because 120 divided by 5 gives you a whole number, 24 is going to be your answer. Okay? So this and this, they mean the same thing, but this is completely simplified because a fraction means division. And in this case, you can write this as a whole number. These are really good questions. These are indice questions that often people get wrong, but we can definitely be getting these correct. Now, if ever you see a negative power, like -1 or -3, it means you take the reciprocal, which means you go 1 over your number. And then the power that you raise your number to is the power given in the question. So in this one, it would just be 2 to the power of 1, and anything to the power of 1 is just the number itself, so just it keeps it as 2. So 2 to the -1 is definitely not -2, it means a half. That's it. The one below, again, because you can see a negative power, it means you go and take the reciprocal, so you go and do 1 over your number, which is 2. And this power is the power given in the question, which is to the power of 3. Now, 2 cubed means this. It means 2 times 2 times 2. And 2 times 2 gives you 4. And 4 times 2 gives you 8. So 2 cubed is the same thing as 8. Okay, so that's important to know. So you can simplify this a bit further by saying, well, it's going to be 1 over 2 cubed, which is the same thing as 8. And you would really have to write it in this format because you can simplify 2 cubed to be 8. So 2 to the -3 is the same thing as 1 over 8. So sorry, the question said to write these indices as fractions. So this is the index form, fraction, index, fraction. Now 4 to the -2, again, because you can see the negative power, you go 1 over your number, which is 4, and you put it to the power that you can see, which is 2. So you put it to the power of 2. Now 4 squared means 4 times 4, which is 16, so it goes to 1 over 16, and this is your answer. Question 12. What time is it? We've been going for about 10, 15 minutes. We've got the square root of 121. Now you can't actually see it, but with the square root, with the basic square root, there is a 2 by the root that you can't see. We just don't write it there because the notation for square root is just, the square root is just given by this. This means what number multiplied by itself gives you 121? And the answer is 11, okay, because 11 times 11 gives you 121. So this is the answer. Now this is not the square root, this is the cube root, which means this time, not what number times it by itself twice, but this time what number multiplied by itself 3 times gives you 8. And the answer is 2, because 2 times 2 times 2 gives you 8. So this is the answer for 13. 14, again, be careful here, it's the cube root, not the square root. So what number times by itself 3 times gives you 125. And this just comes with practice. The more you see these numbers, the more you recognize them. But it is 5, because 5 times 5 times 5 gives you 125. And that is your answer. Now, question 15, these are really good questions that often cause confusion. Now, we've just seen, have we just seen? No, well, a square, if you square something, that means you times it by itself. Okay, so for example, if we just had here the example of 2 squared, okay, if I wrote down 2 squared, well, that would just mean 2 times 2, which is 4. Now, this time, the same thing, you're timesing -2 by itself. So this one you're doing, because squaring is you're timesing your number by itself, but your number this time isn't minus, but it doesn't matter. You're doing -2, you're timesing by -2. Now, this is important. If you multiply or divide 2 negatives, you get a positive answer. So 2 times 2 is 4, and because you're multiplying with 2 negatives, you get a positive answer, which is 4. So actually, right, in bracket -2 all squared is 4, which is the same thing as doing 2 squared, which is also 4. Because if you multiply 2 negatives together, you do get a positive answer. Okay, so this answer is equal to 4. Let's just get rid of this so we don't run out of room. There we go. Now this thing, right, if you cube something, like for example, if you go and do, I don't know, 4 cubed, that would mean you're doing 4 times 4 times 4, which would give you 64. It's the same thing with this over here, but you're just timesing minus 2 by itself 3 times. So this means you've got negative 2 times negative 2 times by negative 2. Now let's just erase this so we've got some more room. Now we've just seen, right, if we go and do minus 2 times by minus 2, you get 4. So on the first two here, this part gives you 4. If you times that by that minus 2 on the end again, well, this time you are multiplying with one positive and one negative. And if you times numbers where one is positive and one is negative, you get a negative outcome. So 4 times 2 is 8, and one of the numbers is negative, so you get minus 8. Okay? Now, a bit of a handy little tool to help you remember this, and there's not a lot of room on the page, is there? But I'll write it up anyway, is this grid over here. So if you are multiplying or dividing numbers, okay, you can use this. Now this is just saying, if you multiply or divide two numbers, if they are both positive, you get a positive outcome. If one is negative and one is positive, you get a negative answer. If one is positive and negative again, you get a negative answer. If they're both negative, you get a positive outcome. Okay, so in the thing up here, because they were both negative and you're timesing, a negative times by a negative gives you positive. On this one, okay, because we had the 4 times by a minus 2, that was positive. With a negative, you get a negative outcome, as you can see down here. Okay. Now, question 17 is a bit of an awkward variation. They might give you in the exam something like, is this up here the same thing as this down here? They look very similar, but you've got a bracket in this one and there's no bracket in this one. Now this is actually really a BIDMAS question. Okay, so brackets, indices, division, multiplication, addition, subtraction. Now because there's no brackets here, you would do the index first. So you would almost ignore the minus and you would go and do, well, 2 squared, 2 times 2 is 4. Okay, it's 4. And then because you've got the negative sign here, you'd write it down here as minus 4. So it's a bit of an awkward one, this, okay, but just be careful that if you've got minus 2 squared in no brackets, the answer actually is minus 4. Okay, it's just a bit something to be wary of. It's from BIDMAS, because here you've got minus 2 squared. You do the bracket part first, which is asking you to do the whole of minus 2 times by minus 2. Whereas this really just means ignore the minus, do the indice first, 2 squared, which is 4, then you use the subtraction. Question 18, again, is a bit of BIDMAS. Let's write this up here. So BIDMAS is, you've got the B is for brackets, index is for powers, you've got multiplication and division, addition and subtraction. Now for this one, you can see you've got a bracket, so you do the bracket part first. Okay, so we look at the brackets. Now you've got a minus and a times, and because multiplication goes before subtraction, we do 3 times 2 first, which gives you 6. So we've got 5. Take away 6, and then we are going to be squaring all of that. Now 5 take away 6 actually gives you minus 1, and we are squaring minus 1. Now this is a bit of an awkward one again, not awkward, but it's a nice one. A bit like up here, we had negative 2 squared, which was minus 2 times by minus 2. This means we've got negative 1 times by negative 1, and we are multiplying 2 negatives, you will get a positive answer. And 1 times 1 gives you 1, so 1 is the answer for this one. Question 19, insert the brackets to make the calculation correct. You could just use a bit of trial and error here, but it is BIDMAS again. Now, where is it going to go? It is going to go to make 34. We'll try this, see if it works. If we did this, because you've got brackets here now, you would do the brackets first. You would do 7 take away 3, which is 4. So you'd have 2 plus 4 multiplied by 8. Now this is going to be the one that works, because now you do the multiplication before the addition. So 4 times 8 gives you 32, and 2 plus 32 gives you 34. So this is where the brackets would go. Question 20, this is like looking at your negatives. Now this is important to make sure we get this. So this is saying you're at minus 2 and you are taking away 5. So on a number line, we've got this here. Cool. we are starting at the number -2. The first number is always where you begin at. And you're just going back by 5. You're taking away 5. So you're at -2, you go back by 5. So it's going to go -3, -4, -5, -6, -7. -7 is your answer for this one. Okay? Now, the whole two negative things makes a positive is only true for multiplication and division. The things we've just seen up here. This is not timesing or dividing. This is just subtraction. So be careful with that. This is not equal to +7. It isn't timesing or dividing. So it just means you're at -2 and you're going back by 5. Question 21 is 5 add -2, which means the same thing as doing 5 take away 2. And the way that I teach my students this is the following. Again, the first number is always where you begin at on your number line, which is the 5. So you begin at number 5. And then you think about it like this. Look at this. When you have two signs, plus and minus, next to each other, you can think of it like this. So consider this part in the following way. You're in a room which is at a temperature of 5 degrees. You then you're adding cold air, where cold air is negative. So if you add cold air to a room, would the room get warmer or colder? If you're adding cold air, it would get colder. So it means you're going down by 2. So a plus minus really just means the same thing as taking away 2. And 5 take away 2 gives you 3. So 3 is the answer for this one. Okay. Question 22. This looks horrific because you've got 3 minus signs, but again, just break it down step by step. Now, the first number is always where you begin on your number line. So you're beginning at -8, okay, which is over here. Now, if you are taking away, so this next part, you consider it in terms of the temperature. So if ever you've got double signs next to each other, that's when you bring into account this temperature analogy. So before we were adding cold air, you got colder. Now, if you remove, you're taking away cold air from a room. If you take away cold air from a room, the room will get warmer. So this really means you're going to get up by 3, because taking away cold air means you're going to go up by 3. Now, -8 plus 3, we're going up by 1, 2, 3. So it's going to go -7, -6, -5. So -5 is the answer for this one. Okay, this one is actually what we were doing previously. This time you are timesing. So this is now going back to this stuff up here. And I put it in brackets, but you could also write it without brackets. It actually means the same thing here. So you could also get this situation here. Now, 5 times 4 is 20, but you are timesing with one negative. Okay, so if you've got a positive with a negative, you get a negative outcome. So -20 is the answer for this one. There we go. Again, this time we are timesing, so we can apply the laws of if you multiply two negatives, you will get a positive. And 5 times 4 is 20, and that's going to be the answer, 20. Okay? Because the whole double negative thing is only true for timesing, which is what this is, and also dividing, which is what this is on. So, question 25, we've got 8 divided by -2. We'll just go and do 8 divided by 2 first, which is 4. And because you are dividing with one negative, back to this thing up here, okay, you've got a positive with a negative, and you are dividing, you get a negative answer. So this goes to -4 in that one. Good, good, good. Now a bit of rounding. So question 26 is saying round the following numbers to 2 decimal places. Now your decimal places are your numbers that come after the points. So that would be your first, I'm going to call it DP for decimal place, your first DP, your second DP, your third DP, your fourth DP. Over here, there's your decimal points. So that's your first DP, your second DP, your third DP. Now your second decimal place for the first number is this 8. It's your second number after the point. And because the number next to it is a 5, okay, and if it's 5 or more, it's 5, oh, let's go and do it in blue. If it's 5 or more, you round up. If it's 4 or less, you round down. because your number to the right is a 5, which is 5 or more, this 8 is going to go up to a 9. So let's go put that in there. So we get 14.29. And then these numbers just become zeros. Okay, so you can just write it as 0.29. And that is your answer. The second one, your second decimal place is, well, that's your first, that's your second is the 2. Your number after it is a 4, and 4 or less you round down, which means you keep this as it is, you keep it as a 2, so it keeps it as 0.02. And then these numbers become zeros, but again, you can just write it as 0.02, so this is your answer. Now, be careful with this one. Significant figures, when you're rounding to it, is different. Now, unlike with decimal places, which occur after your point, your first significant figure is just your first number that is not a 0, which in the first number is a 1. So that is your first sig fig, your second, your third, your fourth, your fifth, your sixth. In this number, your first significant figure is the 2. It is your first number that is not a 0. So just bear that in mind. So identify, first of all, your second significant figure, which for the first number is the 4. And then you apply the same rules as before. You look at your number to the right, which is a 2, which is less than 4. So you round this down and you keep it as a 4. So you keep it as 4, and the 1 stays there. Then these numbers all become zeros, but again, 14.0000 just means 14. And that's your answer. The one below, your second significant figure is the 4. That's your first, that's your second. So there we go. And again, because your number to the right of it is less than 4, you round it down, you keep it as a 4. So you're going to write it as 0.024. That becomes a 0, but you don't need to write it. So this is your answer. Okay. So very important that you can distinguish between rounding to decimal places and significant figures, because you could get a one-off question on it, but also your answers often ask for things to be rounded. Question 28. Now, unless stated otherwise, with estimation questions, and this is very likely to come up on the non-calculator paper because estimation is all to do with not using a calculator, unless stated otherwise, you always round to one significant figure, SF. So you want to round each of these numbers, this one, and this one, to one significant figure. Now, for 3.99, your first significant figure is the 3. So you look at your number to the right, which is a 9, and that means you round this up to a 4. So this just goes up to a 4. Now your second number, be careful with this. Often people would round this to 14. That would be wrong. Unless stated otherwise, unless they tell you to round otherwise, well, your first significant figure here is a 1. And because the 4 next to it, number to the right, is less than 4, you round down and you keep this as a 1, and you replace the numbers afterwards with zeros. So it would go to 1, you replace the 4 with 0, and the 2 with 0, and 10.0 is just 10. So 14.2 to one significant figure goes to 10, not a 14. That's something that always catches people out. 2.1 is more simple. That would just go down to 2, so that would go down to 2 over here. And then you've got 4 times 10, which is 40, divided by 2, which gives you 20. So an approximate answer, an estimation to this question is 20. The one below, again, unless stated otherwise, when you estimate, you round it to one significant figure. And again, your first significant figure here is a 9. The 8 means you round the 9 up to, after 9, you go up to your next place value holder, which is going to be the 100, so it would go up to 100. And you always got to think, right, with these kind of questions, you know, if they gave you the square root of 110, that would never make sense on a non-calculator paper. It's going to have to work out. So the square root of 100 is nice and simple because it's just going to be 10, because 10 times 10 gives you 100. So that's going to be your answer. Okay, we're getting there. Question 29, is looking at the laws of indices. Now, if you're timesing indices, so things with powers with the same base, and you've got to have the same base, you just go and add the powers together. So it's going to go to a to the power of 5 plus 3, which gives you 8. That is your answer for this one. 30 is the same thing, and again, you're timesing. Okay, so you need to add the powers together. So it's going to be a to the power of 5, add minus 3. Now 5 and minus 3, we've seen this before, okay, up. We saw it, where did we see it? We saw it, or similar up here, we saw 5 and minus 2, which really meant 5 take away 2, same thing here. This just now means 5 take away 3, which is 2, so you get a to the power of 2, okay, because this just really means, again, if you're at 5 degrees and you add cold air, you're getting colder by 3. 5 take away 3 gives you 2. There we go. Now, when you divide indices with the same base, so you can see here you've got a base of x and x, you take away the powers. So you go and do 6 take away 3, which is 2. So that's going to go to x to the power... Sorry, I think I just said 6 take away 3 is 2. 6 take away 3 is 3, so x to the power of 3. And then you've got these number parts. You've got 12 divided by 2, which gives you 6. So you get 6x to the power of 3 is your answer. Okay, so you look at the number parts and the indice parts separately. Now this is another law of indice. If you've got a power raised to another power, you know that you need to multiply your powers together. Okay, so 4 times 6 gives you 24. So you get m to the power of 24 is the answer for this one. Question 33 is a trickier variation, but if you ignore the 2 for the time being, okay, so you can almost put your finger over that 2, you've got x to the 4 cubed, the same thing as the previous question, you times the powers together, okay, you go and do 4 times 3, which gives you x to the 12, and then you go and do 2 to the power of 3, and 2 to the power of 3 is 2 cubed, which we know gives you 8, so it's going to be 8x to the power of 12. Your last one, you need to know that anything to the power of 0 gives you 1, so that will just give you 1. So anything, any number to the power of 0 just gives you 1 is equal to 1. So what you've seen from question 29 is basically all of your laws of indices that you need to know, which is the timesing law, dividing law, your power law, and your zero power law. Okay. Now, of course, there is other things that could come under fundamental numeracy skills like prime numbers and cube numbers, but this is kind of what I thought would be quite useful. Okay, so hopefully this is quite useful, and yeah, make sure you have got a good understanding with this kind of stuff, because it will come up on paper 2, probably most of it actually. These questions, at least in some part of the question, you might even get a lot of questions where it just asks you to, for example, times decimals together, or it might ask you to find the cube root of 125. Okay, but hopefully this was useful. Sorry, it's a very rough kind of video. I just made it in the park earlier, so that it's not the highest quality, but hopefully it is quite useful. And of course, you can comment any questions in the comments below. Good stuff, guys. Well done.